string is a very important part of our data, which we deal with every day. Okay, probably we deal with lot of text. Today, your web browsing applications deal with lot of strings. Okay, so what basically these strings are? So what are the different operations you can do with these strings? Okay, and we will study two important applications with respect to strings. One is called as the indexing, and which we call it as what pattern matching, which in Google search and all that does this pattern matching. Like when you give a keyword, so that keyword, what you give in the Google browser, that keyword, that is a pattern what you are looking in the web documents, and Google will perform the searching, and all the documents which contains that pattern will be displayed in your screen. So that is nothing but the pattern matching. So today most of your applications deals with the pattern matching. So what are the different algorithms that are used for pattern matching? We will study two such important algorithms here. And also the second thing is, if you would like to search a given substring in a given string, whether a substring is present in a string or not, like how it can be performed. So that also we will see. So let us, before going into these algorithms, first we will see the few terminologies related to strings, and also the few basic, I mean to say, the operations which you can do with the strings. Now, as you know that every programming language contains a character set through which we develop a program. Okay, so your entire programming language is made of certain characters which forms the character set, which is used to communicate with your computer. So if I take just few examples of these character set, one set of characters we call it as alphabets, where we start from A to Z. It can be uppercase or lowercase. Then we have another set of characters which is called digits, which starts from 0 to 9, and we can have the combination of these digits to make integers and all. Then apart from these two important characters, we have another special characters like all, plus, minus, division, multiplication, parenthesis, all other characters what you can see in your keyboard, including your blank space, they forms the special characters. So this is how we classify your characters into these three important categories. And using these characters, we form the programming program, which will be given to your computer, through which we communicate. So now, how do you define a string? So string is basically a finite sequence of 0 or more characters is called as a string. So a string can be empty, so which we call it as null string. Okay, that means you need not have anything in your string, which we call it as empty string. Or your string can have one or more characters. So string is basically a finite. Why we call it as finite? You should know the length of the string. It cannot be indefinite. It has to be definite. So where the size has to be limited or the size has to be definite. So we call it as the finite sequence S of 0. S is nothing but the name given to the string of 0 or more characters is called as the string. Now, when we define a string, so basically array of characters is also called as a string. So in other way, if you want to define a string, string is also called as array of characters. Array means what? Basically more than one element, we call it as an array. So here also more than one character forms the string. Array of characters is called as the string. Now, then the other terminology which we come across is the length. Now, what is this length? Length of the string. So the number of characters in a string is called as the length of the string. How many characters are there in a given string? Okay, so that we call it as the length of the string. And you also have empty or null string. So what is this empty or null string? A string with 0 characters is called as the empty or the null string. Then we have other operations like what is called concatenation. So when I say concatenation is basically combining the two strings and storing it as one single string. Okay, the second string will be appended to the first string. Okay, and then the resultant will be stored in the first string. That is what the concatenation does. Suppose if S1 and S2 are the two strings which consist a set of characters, and the size of S1 and S2 can be same or it can be different, then the concatenation of S1 and S2 is done like after S1, S2 is appended. Okay, like the string consisting of the characters of S1, which is followed by the characters of S2, is called as concatenation of S1 and S2. For example, if you have the end, okay, and the other one end, then we combine it as the end. So that is how the concatenation is done. The other thing is what you have is the substring. So when I say substring, a portion of the string is called as the substring. Now, for example, a string Y is called the substring of string S if there exists the string X and Z. Okay. Now, for example, S is a total string. In that string, we have three substrings X, Y, Z. Initial portion of the string is called X, the middle portion of the string is called Y, and the end portion of the string is called Z. So just we are dividing certain characters into substrings. So substrings are basically the portions of the strings. Suppose if X is an empty string, assume X is empty, that means there are no characters. Then Y will be your initial substring of S, because your string starts from Y. So Y becomes the initial substring of S. And Z is an empty string. That means if X also is empty and Z also is empty, then Y is the only substring of S. Suppose if Z is empty, X and Y are there, okay, then Y will become the terminal substring of S. That means your string is ending with Y, so your Y becomes the terminal substring of S. So, for example, if you take be or not, okay, so that is the substring in a given string, to be or not to, okay. So your original string is to, be, or not to. That is your complete original string. In that, the portion of the string is be or not. That is like your Y. So it is the middle portion of your string. Even to can be a substring. Even be can be a substring. Any portion of the characters in a given string, we call it as the substring. Then suppose be the is an initial substring of the end. Suppose if I have a string the end, then the is called as the initial substring, because your string begins with the, so it is called as the initial substring, and end is called as the terminal substring. So depending on the position of the substring, either it can be initial substring or it can be terminal substring. If it is the beginning of the string, we call it as the initial substring. If it is at the end of the string, we call it as the terminal substring. Then, as I told you, how do you represent strings in C language? Okay, so in C, basically strings are represented as character arrays, or what we call it as array of characters, which has to be terminated with the null character. Please remember, when you store a string in the memory, after you store the complete length of the string should be terminated with the null character. So why this null character is used? To indicate the end of the string, because in a string you can have one word, two word, three words, you can have blank spaces, you can have special characters. Your string can be made of any character set. So how do you know that your string is going to end? Because it can contain blank space also has a character. So how do you indicate your string is going to terminate? So while storing a string in the memory, so to indicate the end of the string, you will append with the null character. So in C language, strings are terminated with the null character at the end. So that's the reason when you declare the size of the strings, so the size of the string should be length of the string plus 1. Suppose if I want to store JSS, okay, so JSS is of how many characters? 3 characters. But while declaring the array, I will store it as 4. Why 4? 3 is for JSS and 1 is for null character. So that's the reason when you declare a string or when you define a string, which is an array of characters, the length of the string should be 1 greater than the length of the string. That is for null character. So this is how we define the strings in C. Now, these are the few examples how strings are declared. Here I'm talking with respect to C language. So first example where I define max size 100. So here we are using a symbolic constant called max size, whose value is fixed, which will be always 100. Now when I say char s of max size, so s of 100. Now your 100 is fixed. Your max size takes the value, constant value, which is 100. So that means you are reserving the memory for 100 characters. So S is an string of maximum you can store 99 characters, not 100, 99. Why 99? That one will be used for null character. So if at all, if you want to store any string maximum of length 99, you can store it in the array called S. And now in this example, I'm initializing some value. So char of S max size equals dog. So out of 100 size, now you are storing only the string called dog. So what is the length of this string? Dog. But when it is stored in the memory, it will be stored as dog. As soon as G ends, because that is the end of the string, it will be terminated with the null characters. That says that is the end of the string. So S of 0, and each character occupies 1 byte. So you know the size of the character. The size of the character is 1 byte. So the first character, that is D, will be stored in S of 0, O will be stored in S of 1, and G will be stored in S of 2. So what is the length of the string? The length of the string is 3. Please don't include null character to find the length of the string. Null character is used only storing in the memory to indicate the end of the string. But while calculating the length of the string, null character is not considered. So what is the length of the string in this example? DOG, it is of length 3, because totally how many characters are there? 3 characters are there. Similarly, if you take another example, and one more thing, this memory is not contiguous. This is a separate memory and this is a separate memory. Just I've put it in one single block, okay? There's another example called char T of max size equals house. So here T is an string, which is nothing but array of characters. And what is that I'm initializing? House. So in T of 0, H will be stored, T of 1, O, T of 2, U, T of 3, S, T of 4, E. And at the end of the string, you terminate with the null character. So that says that is the end of the string. So as you can see here, this is one way of storing or one way of declaring the string as an array of characters. Please remember, array means more than one. Okay. But please remember, when you store the array, when you store the string in the memory, it should be terminated with the null character. So that indicates the end of the string. So there's another way of declaring the string. So that is char S of, in the second example, we are not declaring any size. We say char S of empty square bracket equals dog. This is second way of initializing. So when I say char S of equals dog, so though I am not considered how much memory should be allocated, but based on the length of the string, memory will be allocated automatically. So in this case, since the length of the string is 3 DOG plus 1 for null character, so yes, how much exactly 4 bytes of memory will be allocated. But in the previous case, how many bytes of memory will be allocated? 100 bytes of memory will be allocated. Out of 100, only how many bytes is being used? 4 bytes is used. The remaining 96 bytes gets wasted, but it cannot be allocated for other variables or other arrays. So the memory gets wasted. So that's the reason you can go for the second type of declaration, where based on what value you store it in the memory, only so much memory will be allocated. So that is how you do. So since dog is of size 3, so 3 plus 1 for null character. So an array of 4 bytes of memory will be allocated, where S of 0 will be D, S of 1 will be O, S of 2 will be G, and S of 3 will be null character. So that's how it will get stored. Similarly, for char T of house, so 5 plus 1. So 6 bytes of memory will be allocated. 5 bytes is for storing house. One character occupies 1 byte. Please remember, character is 1 byte. So H takes 1 byte, O takes 1 byte, U takes 1 byte, S takes 1 byte, E takes 1 byte, and null takes 1 byte. So what is the memory allocated for the array T? So it is 6 bytes of memory will be allocated, where you will store H, O, U, S, E in the first 5 bytes sequentially, and the last 6th byte you will store the null character. So the null character indicates that's the end of the string. So this type of declaration, when you compare the first type of declaration with the second declarations, it will allocate only how much, the minimum space what is required to store a given string. So memory does not get wasted. So this is the best way of initializing the string. Then coming to how the strings are stored, okay. So strings can be stored in using three types of structures, okay. One is using fixed length structures. Second one is using variable length structures with the fixed maximum. And the other one is using the linked structures. So now first we will see how strings are used in fixed length storage, okay. So in fixed length structures, each line of the print is viewed as a record. So when I say printf whatever so and so, the each printf statement will be viewed as a record where all will have the same length. So that is where each record accommodates the same number of characters. For example, assume my input is my program, the C program what I write. So using the record-oriented fixed length storage, the input data will appear in the memory as the picture below. So this is what you can see. So it will take the fixed record. See, all the records are of fixed size. So when I type a program, the first line of my program is like C program printing 2, something like that. The second one is read J and K, if so and so, then print. So what you can see here, all of them are occupying the fixed records. So inserting a new record requires that all succeeding records should be moved to the new memory location because they occupies the fixed record. So if you want to insert a new record into it, so in a particular location, the subsequent record should be shifted. So instead of that, what you can do is you can go for like a pointer. So which basically what you saw in the previous record, it is like each record will be pointed by a pointer. And the address of the pointer will be stored in one memory location. What you can see, the 1 is pointing to the first record, 2 is pointing to the second record, the 3 is pointing to the third record, and the fourth one is pointing to fourth record. So where each record is nothing but the one line of your program, and all of them occupies the fixed size. The main advantage of using this type of fixed length records are ease of accessing. So if you want to go to the third line, just access the third pointer and try to get it. Okay, so this is accessing the data from any given record becomes easier. And updating the data in a given record also is easy as long as the length of the new data does not exceed the record length. So because all the records are of fixed length. The main disadvantage here is the time is wasted reading the entire record if most of the storage consists of inessential blank spaces. So what you can see in the example, only some of the memory locations they are occupied. The rest of the memory locations, they're all blank spaces. So if I want to read the record, I should start reading the blank spaces and then go to the data where it is being stored. Okay. So the time is wasted in reading the blank records or blank spaces. Okay. And certain records may require more space than the available. So as I told you, all the records are of fixed size. Some of the records may require extra space which cannot be accommodated. Okay, so that's the reason we go for like the variable size string. What we have, either you can store it as linked list, or you can store it as an invariable size. Now today, whatever the strings what we declare, like char name of 10 is equal to whatever JSS80. So there it will not use the fixed record structure. It will use the variable size record structures where each records can be of different size and it can be stored randomly in the memory location. So that's how it is used. Now coming to the operations, what you can perform on the string. Okay, so what are the different operations you can perform with the string? So let us see with examples. The first thing is the substring. Generally, when we store a complete string in the memory, the portion of the string can be accessed. That portion of the string is called as the substring. So accessing a substring requires. So if I want to access the portion of the string, from a given string, and that portion of the string we call it as the substring. What are the different information you need to provide? Okay, one is the name of the original string from where you want to retrieve the substring. Second thing, the position of the first character of the substring in the given string. So in a given string, from which position your substring starts, that is the position of the first character of the substring in the given string. And the third information what you have to provide is the length of the substring. Okay, so from second position onwards, where it ends, so where your substring is going to end in your given string, so that length gives you the total length of the substring. So, or either it could be the length of the substring, or it can be the position of the last character of the substring. It both are same. So then how do you call this function? So substring. So basically you are reading a portion of the string, and the name of the function we call it as the substring. So it needs three arguments. First one is the original string, comma. Second one is the position of the first character of the substring, that is the initial position of the substring. And the third argument is the length of the substring. So where S denotes the string, then initial specifies the position k of the substring, and the length specifies the length of the substring. For example, assume I will call the function substring, open the bracket, the end, the space end. What is this the space end? That is your original string. Okay, in the original string, comma, the second value is 4. So what does that 4 indicates? So your substring is going to start from the fourth position of your original string. Now, what is your fourth original position? So what is there in the fourth position of your original string? It's the blank space, because T is the first position, H is the second position, E is the third position, blank space is the fourth position. So from the fourth position onwards, what is the total length of your substring? 4. So what will be your substring you're going to read? Blank space, E, N, and D. So your substring which you are reading from the end is including blank space, that is equal to, so what it will return? It will return blank space, E, N, and D. For example, if the same example, if I say the space end, 2 comma 2, so or 2 comma 1. So that means what? So take for an example 2 comma 1. So that means your substring starts from the position 2 of length 1. So that then what it will return? It will return H, because what is there in your which character is there in the position 2? That is H. And what is the length of your substring? 1. So that means it will return only H. Suppose if you say 2 comma 2, that means your substring starts from the position 2 of length 2. So then it will return HE. So that's how the substrings are used. And please remember, whenever you want to extract the substring from a given string, you need three information. One is the original string from where you want to retrieve. Second one is the starting position of the substring. And the third one is the length of the substring. Indexing. So what is indexing is? Indexing is also called as pattern matching. Now, when I say pattern matching, so as I told you, like today in most of your application, as I told you in Google search and all, like all in your web applications where you need to search a given pattern, I need to list all my documents which contains a given keyword. So what exactly your Google will do? The keyword what you type is the pattern what you're looking for in a given set of documents. So it will list all the documents which contains that keyword or what is called as pattern. So, and it will say whether it is present or not. So that is nothing but we call it as pattern matching. So indexing is also called as pattern matching. Now what pattern matching, so how exactly pattern matching is done? So pattern matching is basically to check whether a given pattern is found in the string or not. If at all, if it is found, in which position it is found. That's all we want to know. Otherwise, if the pattern is not found, so there is no match. So that is what the outcome of pattern matching will be done. So it refers to finding the position where a string pattern P first appears in a given string text T. So your T is your original string and P is the pattern. So now how do I call this function index? So we call the function index, open the bracket, and please remember these are not built-in functions. It is user-defined functions. We have to write the code for it. So, but only the thing is we just give the name so that you will know this function does indexing. So let me call the function as index, and we need to pass two arguments. One is the original text and the second one is the pattern. That's it. because here I cannot give you position because I don't know whether the pattern is found in the text or not. So here my resultant or my outcome of this function is whether this pattern is found in the text or not. Your pattern is P and the text is T. So if the pattern P does not appear in the text T, then the index value what it returns will be 0. That means it will say the pattern is not found in the given text. Otherwise, it will return the position from where the pattern is found. Okay, the first position from where the pattern is found. So then the arguments for the index function, that is both the text and the pattern, can be either string constants or it can be string variables. So what do you mean by string constants or string variable? Directly you can pass the string, like for example, index of JSSAT can my text and AT can be my pattern. Okay, directly I can pass the constant. Constant means directly my string value, or you can store the string in a given string variable and you can pass the string variable as the argument. So that means both the text and the pattern can be either string constants or it can be string variables. So concatenation, as I already told you previously, so it is the other operations which you can do with the string. So concatenation is sometimes you want to combine the two strings into one string. So then you can go for concatenation, where S2 will be added to S1 and the resultant will be stored in S1. Okay, generally that is how concatenation is done. Suppose if S1 is equal to Mark and S2 is equal to Twain, then S1 concatenate S2 will be Mark Twain. And when you do the concatenations, it will be joint. I mean to say, you will not leave any blank space. As soon as you end the first string, immediately you will start joining, I mean to say, append the second string, and the resultant will be stored in S1. Okay. And this concatenation, as I told you, you have a built-in function which can perform this concatenation in C language, which is done by a function called strcat. So what does strcat does? String concatenate. So you need not write your own program like user-defined function. Whenever you want to perform concatenation, you can just call a built-in function, string built-in function called as strcat, where you need to pass two arguments, the first string, that is S1, and the second string S2. So when I call this function strcat, S1 comma S2, the string S2 will be appended to S1 and the resultant now will be stored in S1. So changes will not happen to S2, but changes will happen to S1. Now S1 contains Mark Twain. Just if you take the previous example where S1 is Mark and S2 is Twain, then what will be after concatenation? What will be there in S1? You will have Mark Twain, but S2 will contain Twain. That's it. And as you know that whenever we use these built-in functions for string, like string length, string concatenate, string copy, so you have to include the header file called as string.h. So like apart from stdio.h, so whenever you use string built-in functions, you have to include the header file called as string.h, so that your source program will be linked with the library functions and then you can call the functions. So that is what linking does. So now how do you find the length of the string? So as you know that you have a built-in function called strLength. Otherwise you can, so when I say length of the string, what does it mean? Length of the string basically finds the number of characters in a given string. So length of string means, for example, length of computer. Assume your computer is your string. Now, how many characters are there in computer? 8 characters. Don't include null character. Null character is used only while storing. But while calculating the length of the string, it calculates only the actual characters. So what is the length of computer? It's 8. Now, you need not write a code for it because this is the basic operation which you can do with the string. So you can have a built-in function called strlen. So strlen is the built-in function available in C language which returns the length of the string. So what you have to do is just call the function strlen, and what is the argument you're going to pass? The name of the string. The argument can be directly the string constant or it can be string variable. In this example, it is a string constant. That means you are directly passing the value. So, and here what is your string? The string is sunrise. So how many characters are there in sunrise? That is 7. So string length always returns an integer value, because length is always an integer. That value will be stored in another variable called x. So where x has to be integer. So now when I say print x, it will say 7, where 7 is the length of the sunrise string. And all these, whenever you call this string length function, you have to include string.h, because all these are built-in string functions, or what we call it as string library functions. So you have to include the header file called string.h. So these are the few library string functions which are available in C language, like string concatenate, string concatenate, where if you want to concatenate only a portion of the string to a given string. Then string compare. So string compares the two strings, whether both the strings are same or not. If both are same, then it will return 0. If string 1 is greater than string 2, then it returns the value greater than 0. Then if string 1 is less than string 2, then it will return the value less than 0. Please remember, when I say greater than 0 and less than 0, when it does the comparison, it takes the ASCII value of the characters and it compares. Okay. When I say ABC equals ABC, so it will take the first character A and the first character of the second string A and A. It takes the ASCII value of A and it takes the ASCII value of A. If both are same, then it will go to the second character. So then it will compare B with B. Then if both are same, then it will go to the third character. Like this, it will start comparing each corresponding characters of both the string till all the characters are equal, or either so one of the character is not same. So if all the characters are same, then it will return the value 0. So 0 means both the strings are same. Otherwise, if one of the, suppose if my first string is ABC and my second string is DEF. So when it compares A with D, the first character of the first string is A and the first character of the second string is D. So A is less than D. So when I say A less than D, it is not alphabetically. It takes the ASCII value of A and ASCII value of D. So ASCII value of A is less than ASCII value of D. So in that case, the value it returns is less than 0. So it will subtract the ASCII value of A minus the ASCII value of D, so which you will get negative value, and that negative value will be returned. So that is what string compare does. And then you have string copy. If you want to copy the value of one string into another string, then you can use string copy, that is strcpy. Then you have string length, that is strlen. Then there are other string functions which generally we don't use. So these are the few string functions which generally we come across in our programming. One is string length, one is string copy, string compare, then string concatenate, so and string length. So these are the few string built-in functions which you can directly make use of these functions in your program whenever you have to perform certain operations on this string. The next thing is something called as word processing. Now, what is this word processing? Okay. Earlier, when we used to give the data to my computer, so basically any data which deals with character data. So when I say, like today we talk about text data, we talk about integer data, we talk about like floating data. So whenever we deal with the character data earlier, so mainly it consists of names and addresses. Okay. So the data used to be either the names of the user or some addresses. But today, what data we give to my computer processes the data which is being stored or which is being recorded. Like it can be letters, or it can be articles, it can be reports, where you will have lot of informations. Okay, I mean to say the data is huge. So in that case, we need to perform certain operations associated, and word processing is basically what deals with these handling the huge character data is called as word processing. Okay, so what are the different operations that are associated with the word processing? So there are three important operations that basically deals with the word processing. One is replacement, second one is insertion, and the third one is deletion. Now, what is replacement? So replacing is basically replacing one string in the text by another. Okay. So one text can be replaced by another. Suppose I can replace VTU with Belgaum. Suppose my original string is VTU. Now I want to replace VTU with Belgaum. Then I can go for replacement. So replacing one string in the text by another. Either it can be complete string or it can be portion of the string. So replacement can happen for the entire string, or it can be only for a substring of a given string. So that is, we call it as replacement. And the length of the original string which you have to replace and the length of the replaced string, either they can be same or they can be different. Okay. Then the second operations which we do with the word processing is insertion. So insertion means inserting a string in the middle of the text. I have a huge data. Suppose I'll be typing my report. Somewhere I want to add one extra text or extra word into it randomly in some position. Then I can go for insertion. So insertion is basically adding a string in the middle of the text. So when your Word documents are nothing but what? They are word processors. Okay. So where we type lot of huge documents, pages together, where we do all these basic operations. And here we are dealing with only text. Okay. And the third operation what we do with is the deletion. So if you want to remove a string from a given text, then we can perform an operation called as deletion. So deletion is removing or deleting a string from a given text is called as the deletion. So for deletion, so we will see what are the information that is required to perform all these three operations. One is replacement, one is insertion, and one is deletion. Now, first we will go for insertion. Now, what do you mean by inserting? Inserting a string in a given text is called as an insertion. So assume you have an original text T. Okay. Now, if you want to insert a string S, so S is the string which has to be added to the text T. Okay. Here we don't call the original string as string, because this is something where we deal with huge data. Huge data, we call it as text. We don't call it as a string. So then where you have to insert, in which position the new string has to be inserted. So we need something called as the position K, where the string has to be inserted. So we will call a function called insert, where it takes three arguments. One is the text in which the string has to be inserted. Second one gives you the position where the string has to be inserted. And the third one is the string which has to be inserted, which string you are going to insert. For example, assume I will call the function insert JST. JST is my original text. So in the original text, now I want to insert the string called SA. In which position I have to insert? The third position. So which is your third position? Actually, the where T is stored. Now, from the third position onwards, you have to insert the string SA. So after JS, J is the first position, S is the second position. So after S, immediately you will start inserting the string called SA. So what will be your new text? So after inserting the string SA into JSTE, your new string will be JSSATE. So this is what we call it as insertion, or inserting a string into a given text. So another example is insert Bengaluru. So I assume my original text is Bengaluru, and I want to insert the string GA in which position? The fourth position. So which is your fourth position after N? Okay. So B is your first position, E is your second position, N is your third position. After N, you will start inserting GA. So after inserting, you have to shift all the characters towards right. Okay. So that means GA should be inserted at fourth position. And after inserting the new string, all the characters towards the end, towards the right of the position, you should shift right. It is like inserting an element into an array, which we already saw with the integer data. Here we are doing with the characters. That's it. So that is what we call it as insertion. So I think you can have a look, just an example to see how insertion happens. So this is your original thing, GEEKS, GEEKS, that is Geeks. Then that is your original string or text. Now you want to insert the string called FOR. In which position you want to insert? At the position 4. So where you have to insert? So GEKS, now FOR. So when I say index 4, it is like, sorry, I think it is, index is 1, 3, 4, 5, 6. Sorry. So here there is a mistake. So the position has to be 6. Okay. So from G's onwards, so in the 6th position, you are going to insert. Okay. So that is GEEKS, then FOR, then GEKS will be shift towards the right. So there's one small mistake. You just correct. So here the position is 6. Okay. So suppose if you talk with respect to index of the array, then it is 5. If you talk with respect to position, because please remember, when we pass the argument, it is always the position. Okay. So here the position is 6. 6 means in an array, it will be 5th index position, because array starts from 0. So it will be position minus 1, that is nothing but 6 minus 1, that is the 5th index position. So that's how insertion is done.